All right, you should have 9-3 in front of you. Here we go. If you went to the bank and opened an account with $10,000 principal, that's how much money you put in there. That compounded at a yearly rate of 10% for 3 years, how much money would you have in 3 years? So for the slowest possible way to calculate this, and again, we're going to work out faster ways to calculate this, would be say 10,000. What is 10% of 10,000? That would be multiplying by 10 over 100. So 10% means cancel out some zeros, and I get that I would get $1,000, which means at the end of year one, I'd have $11,000. Great. Now looking at this and trying to clean up my mess so I can do this a little faster, I would notice that what I did is I multiplied by 0.10. Does that make sense? All right, so now I'm going to take what I got here, 11,000, because now I want to figure out how much I have at the end of year two. And I would multiply by 0.10, and I would get, by the way, I said 11,000 right here. You understand that we had 10,000 to begin with, so we still have 11,000, right? So 1,000 again plus 10,000 I started with. Okay, so then it's 11,000 times 0.10, and I would get that's 1,100 plus the original 11,000. I get 12,100. I might notice another thing that might speed me up. If I was just to multiply by 10% plus add on my original amount, well, that'd be 0.10 plus 1, wouldn't it? And so what I really could do here and really speed this up, I could say I had 12,100, and I can multiply by 1.10, couldn't I? And I just go straight to the answer. Of course, at this point, I'm using my calculator. And so I would go 12,100. That's not right. 12,001. Nope, that's still not right. 12,000. Wow. 100 times 1.1, and I get 13,310. And that's how much I'd have at the end of 3 years, and I'd be independently wealthy. Right? Now, looking at this going, wait a second. What I really did is I multiplied by 1.10 3 times, right? I did it the first time to get 11,000. I multiply a second time to get 12,100. I took the 12,100, multiply 1. So what I could rewrite this as 10,000 times 1.10 to the third power. And if I put that in my calculator, recommend doing that right now. Not that I don't know what the answer is going to be. It's $13,310. Okay. Generalized formula would look like this. You take your original amount, which I'm going to call N naught. So it's my original amount. I'm going to take 1 plus my rate. Okay, that's the interest rate I'm getting. To the N. Nope, let's not use N. Let's use T. That'd be better because I have an N over there. So that's T. And this would be number of times I compounded the interest. Okay? And that would be equal to how much money I have. So far, so good. So that's a generalized formula. So given the generalized formula, now we're going to take a look at problem number 1. Everybody try problem number 1. We've got $1,000 in principal. It gets 8% interest compounded yearly for 10 years. How much money could you expect? Try that out right now. And when you are done, we'll try that problem together. All right, here we go. For number 1, hopefully you've had a chance to try it. I'm going to go slowly at the beginning and then we'll rip right through it. The final amount is equal to the initial amount, 1 plus the rate, how many times it's been compounded. So I look at this and I go, well, initial amount was 1,000. 1 plus, what's my rate? It's 8%. Now I write 8% as 0.08. Compounded yearly for 10 years. Nice. So now I go ahead and try this thing out. I go, well, 1.08 up to the 10th power, and I get 2 point that. Now I got to do it right order, right? So this becomes 1.08 to the 10th power We know from order of operation, I got to do this first, right? I'm going to do 1.08 to the 10th power. And so I get n equals 1,000 times, when I put this in the calculator first, I get 2.1589, etc. Multiply by 1,000. Whoops. Multiply by 1,000, and I get that the amount of money I would have after 10 years is $2,158.92. We're going to round down for money because that's what the banks do to you, because they love you. They just chop until it reaches the next level. So far, so good? All right, everybody try the next one. So I'm going to turn this thing off for a moment and then pause it, and then we will be ready to start the next one. All right, Sally goes to bank, put money on. She puts money in. She discovered the CD will pay her 100% interest at 30 years. She gets 3% compounded annually for those 30 years. If she puts in $1,000, which would make her more money. All right, let's do it. So we would go n equals n naught, 1 plus r to the t. Final amount I don't know. My initial amount was 1,000. 1 plus, I want to make 100% interest, so that'd be 1. How many times are I going to compound it? 1 time, right? In 30 years, I'm only going to do it once. So that was a big waste of time because that's just 2,000. Agreed? Now I'm going to try the 3% version. That's a little more work. So I got n equals n naught, 1 plus r to the t. N naught is going to be 1,000 still. 1 plus, now our rate's going to be 0.03, remember, percent. Going to have to write as 0.03. Okay. And then how many times we compound it? Well, it's once a year for 30 years. That'd be 30 times I'm going to compound it. Now give me n, so we got n equals 1,000 times 1.03 to the 30th. So 1.03 up to the 30th times 1,000. And look at that. 2427.26. You'll note the following. 3% interest is more than 100% interest if it compounds enough. Good enough. Now this leads to the thing that most confuses people when they're trying to figure this thing out. I would read through that next paragraph, take a look at it, and then I'm going to try to explain because it is not fun. Well, it's fun, but it's not fun. Just like talking to myself instead of talking to a class. All right, let's give it a whack. Banks quote you an annual interest rate, but they're compounded your money monthly, which leads to some confusion. If a bank was going to give you 6% interest annual compounded monthly, what is the rate at which they would actually compound on a month? In other words, you're getting your money every month, but they're not going to tell you that. They tell you give 6% annual interest. So what do you get for the month? You would get 1/12 of it, right? So you would get, doing this out, you would go n equals n naught, 1 plus r to the t. You would go, so we get n equals n naught, and the rate they're actually going to give me is 0.06, 6% divided by 12 when I go to do the math. Does that make sense? So that's how I change our problems. We realize that we got to reduce our interest rate. The reason why the government allows banks to do that is because if they tell you that they're going to give you a 0.5% interest rate, you would go, no, I don't want that. I want the 6% interest rate. And the 6% when compounded once a year is less than the 0.5% compounded monthly. So that's why they let you do that. But it's still a little confusing. So let me try example number 1. Let's take a whack at this. I'm going to pause it right here, let you have a chance to do the problem, and then I will start it up again. Or actually, we'll start it up again when you guys are ready. All right, so here we go. Bob goes to the bank, puts $1,000 in. So n naught equals $1,000. We look at our rate. We go, 8% interest. Love it. Then we realize compounded monthly. Aha! So divide that by 12. How much money could he actually expect? How much time? Oh, in 10 years. 10 years. Okay. So here we go. There's 2 little tricks you got to watch out for. N equals n naught. 1 plus r to the t. N equals 1,000. 1 plus 0.08 over 12. And can we explain that? They say 8% interest. They compound it monthly. They're going to divide it by 12 and give you 1/12 of it each month, which is still a deal for you. It's actually better than 8% annual. Here's the tricky part. How many times are they going to compound it? Well, if they're doing it once a month for 10 years, that's 12 times 10, or 120 times. How many times are we going to compound it? Yes. Yeah. So here we go. So we got to figure this thing out. So we do a little math. We go n equals, we go 1,000. We go 1 plus 0.08 divided by 12, and I get 1 plus that, 1 plus answer. And I get 1.006666 repeating to the 120th, right? I take that, your calculator can handle 1/20th. Is modern technology wonderful? I got n equals 1,000 times 2.21964, etc., times 1,000, and you get n equals 2219.64, and that's how much money you have after you get 8% interest for 10 years and you start with $1,000. Fair enough? All right. All right, so you should be able to do number 2 without much ado. Everybody try number 2. That's some good examples there.